Professor. Today I'm going to walk through my project where I built a machine learning model to predict whether a tweet was written by a real celebrity or if it was generated by AI. The goal is to explore how we can use modern modeling techniques to spot synthetic content, which is becoming super relevant in digital spaces now. It's really hard to tell, so this may give a little bit of an insight into that. So to start, the business problem. Really, the problem boils down to one thing. Can we build a model that accurately predicts whether a tweet is authored by a celebrity or if it's generated by AI pretending to be them? That's the data science problem that comes from the business goal, which is for a couple of different groups, social media managers and teams and celebrities and people who are customer facing, posting on social media. There's many reasons why they would or would not want their content to be clocked as AI. And also for misinformation. If there is AI content, then people could be taking that as true validated things, and it just might not be. So the data science problem we're going to dive into is a classification model. So first I start with a neural network that I do sentiment analysis with, and then a random forest classification to flag if something is AI or if it was written by a real celebrity. So how do we know? The data. So first, the data comes from a hackathon project called TweetLike. This was several months ago. People combed through data from 2016, 2014, and collected it together for this project. Now, the public version posted on Kaggle is a trimmed, cleaned, and restructured version of it. So no data cleaning is needed. I did add my own data, which we'll get into in a second. But so the data is trimmed. It's only 40 rows, I think. It's 8 celebrities with a couple of tweets each. And it flags if it is AI generated or if it was a real tweet by a celebrity. Now, my data, I just combed through celebrity tweets recently. So all 2024 and 2025 only tweets. The 2 most recent tweets by each celebrity, except for Ariana Grande, because she deleted her Instagram or Twitter account 3 years ago. So the other people, the other 7 celebrities, which that did need a bit of cleaning, and we'll get into that later. Milestones. So how do we know that the data is actually true? So the original tweets were from 2014, 2016. This is before this like big boom in AI. And then several years later, November 22, that's when ChatGPT was released by OpenAI. The buzz really started January 2023, explosion, super fast growing. So that is several years after the tweets were originally made. And then after that is when this project was done with so it was put into like ChatGPT or another source to make tweets in a similar language as the original tweeters, compared them to those tweets. And then my bonus tweets come from, again, 2024, 2025. Now, what methodologies diving into this? So the task was to get 2 from 2 different sections of the course. I'm choosing week 11 neural networks. And actually, this one's kind of interesting. So the type of use case I wanted to use the neural network for is sentiment analysis. So I wanted like just straightforward sentiment analysis, positive, negative, coming from the tweets. And then I also wanted like emotions. So like happy, sad. There's a list of them later. Anger, fear. And what this is going to do is allow for this to be put in several different applications. So all that is needed in order to replicate this project is the name of anybody and then the tweet itself. So I wanted to add new features in order to be able to accurately predict on stuff. And that feature expanding comes from the neural network. Then the actual prediction happens from week 7's decision trees ensemble methods. I chose to do a random forest classifier for a couple different reasons. One of them listed here is that feature importance. So this flags feature importance. This can be super useful for the business application to know what types of emotion, sentiment are really the driving force in people or this model, like this model predicting if a tweet will be or social media post will be flagged as AI generated. Also, the random forest classifier just worked really well with this data with the number of dimensions and the mostly numerical values that I'm using. All right, let's dive into the dataset analysis. So here is the project. So this is the R pubs that I'm going to also submit in the submission. Importing the data, I saved it as a CSV file in my GitHub for reproducibility. And this is what it looks like. So just name, tweet, and then if it is real or if it is not real. Little Boolean value there. And like I mentioned before, this is already cleaned. So I did like just a couple tests and everything looked good. So no cleaning needed. Now the feature analysis. So 2 neural networks, a Python emulator for each of those. I used Reticulate so that I could get transformers and torch in order to do the classifiers. So here's me doing the classifier for sentiment analysis. I wanted to get a sentiment value and a sentiment score. And then I also converted the sentiment value to binary so that we can use it in the predictor. But the sentiment value is just positive or negative, and then the sentiment score is how strong that sentiment is. And now emotional predictors. So another classification that I pulled from Python library, or the function comes from Python. So here are the emotions: anger, disgust, fear, joy, neutral, sadness, and surprise, which were a couple of the big ones that I called from the Python function. And this is what it looks like. So we've got name, tweet, if it's real, raw sentiment, sentiment value, and then some scores. And what it looks like in the data itself, it's kind of jumbled up like this, but the name, the tweet, if it's real, then the new columns, new features. So now that we've got all that taken care of, I split the training data out 80-20 and did some predictions. Taking all the numerical columns, setting seed, training a random forest classifier. So basic training. And then I wanted to predict on the test set and evaluate the performance. So this is interesting. It was all true. Everything was accurate, not true, but everything was accurate. So it clocked the false tweets as false and clocked the true tweets as true in every case of it, which I've never done a machine learning project where that happened, where there was no error, but it's also a pretty small data set, and that could have something to do with it, but it could also have something to do with the fact that AI may not be great at mimicking a person's actual tone and language and what they would say. All right, now these are feature importance graphs. This is exciting for people on the sending side of tweets and social media posts. So these higher values are things that flagged as false or true. They just had a lot more to do with whether or not a tweet was flagged as true or false. So things with fear could either, it's very polarizing. So something with fear, maybe you should think, is this an AI tweet? Is kind of what these graphs are trying to talk about. And that is it for the actual predictors. So now here are my bonus predictions. I took a couple of different tweets from Twitter, grouped them together, and here's what I did to do the same thing. Literally, it's the same thing. It did need a bit of cleaning, so I did do some cleaning. Um, because there was a bunch of stuff in the tweets that just was not good for my predictors. But again, I used Torch and Transformers from Python to add the same sentiment analysis and then export it to a CSV. So then I predicted on it. So I used the exact same predict model, RF model from before. So it's using the same training data as before. And then it predicts on that with these new tweets. And as we see, mostly false. That means that this model believes that all but 3 of these tweets have AI generation in them, which is very interesting. Now, I will say that could be because these were trained on really old data, some of it from 2014, 2016. So these people might have new styles, they might have PR teams, lots of new things that they're working on. There could be many reasons, but just interesting it thinks so much of it is false. All right. So that's the data set analysis. Now, the conclusion, more of the business impact. Again, computer-generated posts. So there are 3 main groups, 2.5 main groups of people that would really benefit from an analysis like this. Social media teams, celebrities, people who are doing the posting. This could be really helpful for moderation mods to kind of flag things as being genuine versus being AI generated. And could also be good in this as public figures and high stakes communications. So something like a live event happening. Is it a bot that is doing these tweets, or is it an actual person? Which kind of bleeds into the second thing, cybersecurity or brand protection. So that is cybersecurity. Are we getting misinformation from bots that are posting that we think are genuine people? Also, brand protection. An instance of this would be what's happening right now with Duolingo. Duolingo's getting a lot of hate because they have turned over a lot of their processes to AI, and now users are interacting with AI a lot more. People do not like that. They are getting a lot of hate, and a lot of people are canceling their subscriptions. Just, it's not going well for them right now with that. So in the same light, if a brand is seen as using AI posts, then that could be a big problem for them, or maybe it's part of their brand identity. Just something that's really good to know. Then the next like completely separate group is social media users. Knowing whether what post you're looking at is generative AI versus made by a person or a team of people, help people to make more informed judgments. So is this something that, like, just giving people more context with what they're interacting with so they know. All right. And then I'm going to end with a little quote. As generative AI becomes more common, the ability to detect machine-written posts is a powerful tool. And it was written by ChatGPT, just typed away. So I thought that was a little funny thing to end on. Then below are my links. So the main logic, and then the bonus tweets, like that separate RPubs that I showed. And then there's my GitHub that has all of my sources. So thank you very much.